Hello and welcome. In this lecture, we are going to study about the Fourier series. So let's get started. The definition of a Fourier series is as follows. Let f of x be a function with period 2 pi and is a piecewise continuous function on interval from minus pi to pi. Then the formula of Fourier series is as follows, where f of x equals a naught by 2 plus summation from n equals 1 to infinity an cos nx plus summation from n equals 1 to infinity bn sin nx. This is called a Fourier series of a function. Now, in this formula, the formula is stated as a naught by 2 plus summation from n equals 1 to infinity an cos nx and summation from n equals to 1 to infinity bn sin nx. These two terms are expandable. As we put the value of n equals to 1 here and here, then we get the value of first function. And similarly, we put the value of n equals 2 here and here, then we get the second value and third value similarly up till infinity. So this formula is known as Fourier series formula. Now in this formula, value of a naught, an and bn is as follows. The value of a naught is 1 by pi from integration from minus pi to pi f of x dx. Similarly, the value of an is equals to 1 by pi integration from minus pi to pi f of x cos nx dx. And in the third, we have the value of bn equals 1 by pi integration from minus pi to pi f of x sin nx dx. These three values are known as Fourier coefficients on the interval from minus pi to pi. So now let's just move and solve the examples based on this formula to get a better understanding of this series, Fourier series. So the question here is, let f of x be a function of period 2 pi such that f of x, the value of f of x is given as pi by 2 on the interval from 0 to 2 pi, and we are asked to find the value of Fourier series of a function f of x over the interval from 0 to 2 pi. So now let's just move and solve this question. The first thing we are going to do here is write the formula. What's the formula? F of x equals a naught by 2 plus summation n equals 1 to infinity an cos nx plus summation n equals 1 to infinity bn sin nx. So now we are required to find the value of a naught, an and bn. So let's just write the formulas of these and find the values. First we have a naught. So a naught, the formula of a naught is as follows. 1 by pi integration from 0 to 2 pi f of x dx. The value of f of x is pi by 2. So let's just put the values of f of x. 1 by pi, 0 to 2 pi, pi by 2 dx. In this formula here, now just put the value 2 out of this integration. So we will have a required solution as 1 by pi, 1 by 2 pi. Put the value of 2 outside of this integration from 0 to 2 pi x dx. Now we will solve this integration. The integration of x is x square over 2. The limit is from 0 to 2 pi. So now let's just put the limit here. A naught equals 1 over 2 pi. We have limit x square over 2. Limit is from 0 to 2 pi. So now put the limit in this formula. 1 over 2 pi square over 2 minus, when we put the value of 0 in this equation, we will get 0. So a naught equals 1 over 2 pi 4 pi square over 2 minus 0. So this comes out to be 1 over 2 pi 4 pi square over 2. Here cancel these. So we will have a required answer as a naught equals pi. This is the required value of this coefficient a naught. Similarly, we will solve the values for an and bn. So now let me just write the formula for an. An equals 1 over pi integration from 0 to 2 pi f of x cos nx dx. Put the value of this function f of x 1 over pi 0 to 2 pi. The value of f of x is x by 2 cos nx dx. put 2 out of this integration, so we will have 1 over 2 pi 0 to 2 pi integration from 0 to 2 pi x cos nx dx. So now we'll solve this integration, and this integration is solved by integration by parts. This is the first function and this is our second function. So the value of these two integration is solved by the integration by parts. So what's the formula? Let me just write here 1 over 2 pi first function as it is, integration of second function. So the integration of cos nx is sin nx over n over the limit from 0 to 2 pi minus whole integration 0 to 2 pi determinant of first function, the determinant of x is 1, integration of second function, so the integration of cos nx is sin nx over n and dx. Let me just write here 1 over 2 pi x sin nx over n from 0 to 2 pi minus whole integration from 0 to 2 pi 1 dot sin nx over n dx. When we put the values of integration here, we will have 1 over 2 pi sine 2n pi over n minus when we put the value of 0 in this, we'll get the 0 as answer. So this minus integration from 0 to 2 pi sine nx over n. Now let's just solve the integration of sin nx over n. The integration of sin nx over n, let's just put n out of this integration, so 1 over n minus the integration of sin nx is minus cos nx over n bracket close, integration from 0 to 2 pi, this whole bracket closed. So we have here 1 over 2 pi. As we know that the value of sin 2 pi is 0, so this whole equation becomes 0. So we have here 0 minus 1 over n. Let's just put the integration, take out the minus, we have plus here. Now let's just put the values of these limits in this value. So we have cos 2n pi minus, when we put the value of 0, we'll get cos 0. So as we know that the value of cos 2 pi is equals to 1 and value of cos 0 is also 1. So let me just write here an equals 1 over 2 pi 0 plus 1 over n 1 minus 1, and anything multiplied by 0 is also becomes 0. So now we have an equals 1 over 2 pi 0 plus the value of an becomes 0. Now let's just find the value of bn similarly. The formula for bn is 1 over pi integration from 0 to 2 pi f of x sin nx dx. So put the value of function 0 to 2 pi, we have x by 2 sin nx dx. Now take out the value of 2 from this integration. We have here 1 over 2 pi integration from 0 to 2 pi x sin nx dx. We will again solve this by integration by parts. So this will be a first function and this is second function. So let's just solve it. 1 over 2 pi first function integration of second function. The value of the integration of sin nx is minus cos nx over n. Let me just write here minus integration from 0 to 2 pi minus whole integration from 0 to 2 pi bracket determinant of first function which is 1, integration of second function which is minus cos nx over n dx. We have here 1 over 2 pi. Let's just put the values of these integration, take out minus, we have 2 pi cos, let's just put n out of this bracket, 2 pi cos 2n pi minus 0, and then we have plus, take out this minus out of this bracket, so we will have plus. Let's just solve the integration. The integration of cos nx is sin nx, so put the value of n out of this bracket, sin nx over n, and the integration from 0 to 2 pi. The integration of cos nx is sin nx over n, so the integration and the limit is from 0 to 2 pi, so we just wrote the limit here. Now let's solve this. Here we have 1 over 2 pi minus 2 pi over n. The value of cos 2n pi equals 1. So we have here 2 pi by n plus 1 by n square, take out the value of n, sin 2n pi minus sin 0. The value of sin 2n pi is equals to 0 and value of sin 0 is also 0. So let me write here 1 over 2 pi, and anything multiplied by 0 becomes also 0. So this whole equation becomes 0 and we only have this right here. So let me write here minus 2 pi over n. So we will cut out 2 pi by 2 pi, so we are left with value of bn equals minus 1 over n. We calculated the value of a naught, an and bn. The value of a naught is pi, the value of an is 0 and value of bn is minus 1 by n. So now let's just put all these values into our required formula. Let me write here the formula. F of x equals a naught by 2 plus summation from n is equals to 1 to infinity an cos nx plus summation from n is equals to 1 to infinity bn sin nx. So we have f of x equals, put the value of a naught which is pi, so pi by 2 plus this whole equation becomes 0 because we have an equals 0. So we have 0 here plus this equation becomes summation n is equals to 1 to infinity 1 over n negative sin nx. When we further solve this equation, we have f of x equals pi by 2 plus summation n is equals to 1 to infinity. Let's just put this minus out of this bracket. So we have here minus 1 over n sin nx. Let's just expand this value. So we have f of x equals x by 2 minus, when we put the value of n is equals to 1, we come up with sin x. Similarly, when we put the value of nx over n by 2, we'll have sin 2x over n, and when we put the value of n 3, so we will have sin 3x over n. The value of n is 2 here and 3 here, so 2 and 3 plus and so on. This is the required answer of this question.